the review for 11.5 through 11.7. First problem is to rewrite this in exponential form, which means the base is 11, 2 is now the exponent, is equal to 121. In problem number 2, they want us to do the opposite, which is to take this 2 to the third equals 8 and equal it to, or make it into a logarithmic equation. And so once again we have log base 2, the 8 and the 3 switch sides, where the exponent is the answer. For problem number 3, we are given log base 9 of 27. And the easiest way to do this is to take the change of base formula, which is the log of 27 divided by the log of 9, which turns out to be 1.5. Remember, when you do this, to end the parenthesis, especially around the 27. Alright, for problem number 4, we have this equation that we're trying to solve for x, and based on the property of equality, the log base 7s are unimportant to this problem. Subtract 5, 3x equals 16, divide by 3, it doesn't come out even, so my answer is going to be 16/3. For problem number 4, we have the log base 7 of x minus the log base 7 of 2 equals the log base 7 of 4. So because subtraction means division, we have the log base 7 of x divided by 2 equals the log base 7 of 4. Once again, these logs now can be canceled out because we have them on both sides, and those are the first thing on both sides and the only thing that are logs, so we can use our property of equality. Once those cancel out, to get rid of the 2 on the bottom, we multiply by 2, and 4 times 2 is equal to 8. And there's our answer. Sorry, that was actually not problem number 5. This one was problem number 4. And so we move on to problem number 6, which says the log of 7 to the third power divided by 4, which is simply a plug this into your calculator and you can get yourself an answer. Now make sure that all of this is inside the parentheses and that you use the log button. And it turns out to be 1.933. For problem number 7, it says to use the change the base formula. So that means we once again can do the log of 25 divided by the log of 3. And we get the answer of 2.92, actually 2.93 when I round it properly. For problem number 8, we have we have 4 to 3x minus 2 equals 3 to the x, and it says you can use your graphing calculator to find. So we're going to do 4 to the 3x minus 2 in parentheses. If you're not sure if your operating system can handle it not in parentheses, it's always wise to put it in parentheses. And then in y2 you just put 3 to the x. After you do this, I would probably, in case something happens, hit zoom 6 so that you get the same graph as everybody else. And then you hit the second button, trace, 5, enter, 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 so 3 times. And you're looking for the x value, which is x equals 0.906. Alright, for the antilog of 3.1761, we use base 10, so 10 to the 3.1761. I'm not sure if these are actually going to be on the test, but antilog means to take 10 to the power, so we're going to get 1500.0. And if it says anti-ln, that just means e to the 10.62, which gives an answer of 40,945.6. Okay, log base 7 125, and this time it says in the directions to use the natural logs to solve it. So I'm going to do the natural log of 125 over the natural log of 7. And you should get, remember to end your parenthesis after the 125, 2.481. For problem number 12, we have 5 to the x equals 70. So we take the natural log of both sides so that we can bring the x down. And then I divide both sides by the natural log of 5. And so the natural log of 70 divided by the natural log of 5 is x equals 2.64. For problem number 13, we're talking about something that compounds continuously, and we want to know the amount of time it takes to double. So I basically use this, where I start out with 1 and wind up with 2, and then it says the rate is 6%, and we're trying to figure out what t is. So what I'm going to do is I'm going to take the natural log of both sides, because the natural log and the e will cancel out because they're inverse operations. And so I'm going to divide by 0.06. So the natural log of 2 divided by 0.06 is 11.55. Now in part B, and for those of you who have watched this video, you know we're going to get to this point where we take the natural log of whatever the rate is, the natural log of 2, because we're doubling, divided by the rate, which is 0.102. And so when I change my rate in the calculator, it turns out to be t equals 6.8 years. Alright, for this next one, you want to go to Stat and Edit, and you want to plug in your time in L1 and your population into L2. And once you have that done, in order to find the exponential equation, you need to go to Stat and then go to the Calculate menu. And the exponential regression is down at number 0. And then L1 should be the first one, and L2 should be the y values. And so you should get y equals 20.39 times, that's not a good looking 9, and then 1.27 to the x. So when you want to figure out, so that is my answer for part A. For part B, you plug in your 20 hours, and whatever that answer is going to be in thousands. So 20.39 times 1.27 to the 20th means we got 229.4 thousand bacteria. And that's our review video.